I'm actually recording this worksheet. Now there's already videos uploaded, but I just wanted to go through a couple of questions on each side. On one side of your worksheet, we have equations that are given to us and they're parallel to our line, okay? So they want you to, just like on the other worksheet, write an equation in slope-intercept form of the line that passes through the given point and is parallel to the given equation. So they give you a point, they tell you that it passes through a given point, and they tell you that your line is parallel to the given line, and parallel means same slope. Okay, so which one would you guys like to try on this first part of the worksheet? 5 it is. Okay, so let's all go to number 5. And I'm actually going to do this one 2 different ways, okay? The first way is to recognize that they give you a point, x1, y1, and they indirectly give you a slope. Okay, they indirectly give you a slope. How's that? Because on the instructions it says that this equation that they give you is parallel to your equation, and if you know that it's parallel, then you have to have the same slope. So the only thing you're going to take out of this equation is that your slope will be the exact same thing, 4/3. You never need to look at this equation again once you already pull that information out. Yay? Okay, now from here, since you have a point that they gave you and indirectly a slope, since you have a point and a slope, what form would be good to use? Point slope form, which is y minus y1 equals m parenthesis x minus x1. And when we use point slope form, I recommend going with blank spots, writing whatever's in black, like right there, and simply plugging in your y1 value of 3 right there, plugging in your x1 value of 12 right there, and plugging in your m value that they indirectly gave us, that I wrote down right here, into the m value right there. So that's going to be a 4/3. Now, if they told us write it in point slope form, we would be done. That would be the answer, right? Or the equation in point slope form. But they want it in slope intercept. Now, slope intercept, if you look at the board, is y equals mx plus b. It doesn't have parentheses. So we want to get rid of the parentheses, and the way to get rid of parentheses when you have multiplication in front is to do the distribution of that multiplication. So 4/3 times x, that is a 4/3 x. 4/3 times minus 12. Now, think about it, guys. 12 is really over a 1, and you could multiply 4 times 12, and that would be 48, and then it's going to be over 3 times 1, which is 3, and 48 over 3 is 16. Or another way of doing it is recognizing that the number on top, you're trying to divide it by the number on the bottom. So you can't go 4 divided by 3. You can't do that. But 12 is divisible by 3, right? You could actually do that. You know what? It's probably better for me to just show my work on the side. I apologize. 4/3 times, let's say, 12 over 1. Okay, so you could multiply and then reduce, or you could reduce first and then multiply. What do you guys want to do? Reduce first. Okay, so the 12 divided by 3, 12 divided by 3 is 4, 3 divided by 3 is 1. And of course, 4 times 4 is 16, and 16 over 1 is simply 16. But of course, we have a minus sign in front of that 16. And we still have the equal sign, the y, the minus 3 in front. And to get it in slope-intercept form, we're going to add 3, and that'll be our slope-intercept form equation. Y equals 4/3 x minus 13. How's that? Is that right? Okay. Now, let's say you didn't want to deal with point slope form even though they gave you a point and a slope. Let's say you wanted to stick with slope-intercept form. Okay. So I'm going to show some work right here in this area. Let's say I wanted to stick with y equals mx plus b. Well, I would put my y value of 3 right here and my x value of 12 right there. Even before doing that, I need to understand that for me to write an equation in slope-intercept form, I need an m, which I have, and I need a b, which I don't have right now, in order for me to write in y equals mx plus b. So I could take what they give us, the x, the y, and the m, and plug it in, the x, the y, and the m, to solve for b. And then once I have my b, then I could write my y equals mx plus b, whatever that b may be. Sounds weird. Okay. So what is y? Y is 3. Equals, what is m? M is 4/3. And we are multiplying by x. So we're going to multiply by the x value of the coordinate, which is 12, and then plus b. And of course, when you multiply 4/3 times 12, again, you could multiply top with the top and then worry about dividing by 3, or you could divide 12 divided by 3, get 4, and then multiply 4 times 4. I want to go with the second option, canceling 12 and 3, getting a 4, and then 4 times 4 is 16. So we have 16 plus b equals 3. Final step would be to get rid of that 16 by subtracting 16, giving us negative 13 equals b. And now we know that b equals negative 13. So if we knew the m value, 4/3, and now we know the b value, negative 13, then we could write our equation in y equals mx. M is 4/3 x plus b minus 13. So it's just another way, if you look down here, it's the same exact equation. It's just another way of doing it. I personally prefer when they give me a slope and a point, I prefer using point-slope form and then simply distributing and then moving to get in slope-intercept. But some people might prefer to just stick with slope-intercept all the way through. So if you're sticking with slope-intercept all the way through, what you ultimately do is you substitute the m, the x, and the y. You substitute the m, the x, and the y, all three of them, you substitute them in, and then you solve for b. And then once you have that b, you substitute the m and the b back into your y equals mx plus b. I don't know, what do you guys think? Is point-slope form better or sticking with slope-intercept form better? Point-slope, raise your hand, let me see, just want to see. How about y equals mx plus b? Sticking with that only one. A couple of you. If you guys like that second option, go for it. All right. You don't have to go with point slope form the first way. So that was the first side. And there's a back side. On the front side, it says that your line is parallel, which means same slope. On the back side, it says that your line is perpendicular. Now, what does that mean, that your line is perpendicular to the other line given? The opposite sine and reciprocal. Yes, no, opposite reciprocal slope. What does that mean, opposite reciprocal slope? That you change sign and flip fraction. Now, on the previous problem that we just did, it was really easy to see our slope because the equation that they gave us was in slope-intercept form and you could see the m value. Okay. Now this one's in standard form right here. This one, number 15, it's in standard form. So they're telling us that our line is going to pass through this point and it's going to have a slope that is perpendicular to this slope. But the problem is I don't even know what this slope is. So yeah, that's a good way of looking at it, Andrew. It's the same process as the last one that we did, but we first need to identify what the slope is here because it's in standard form. So let's get the y by itself. So we're going to subtract 4x. And the reason why I'm getting y by itself, guys, is because it's in standard form. ax plus by equals c. Nowhere in standard form could you see the m value. You could only see the m value in slope-intercept form or point-slope form. So I'm going to take this standard form and change it to slope-intercept. So what I have here is a y equals negative 4x plus 7. That way I could clearly identify that my slope is negative 4. Are you with me? Now that's the slope of the line that they gave me. But what's my actual slope going to be if it's perpendicular to that slope? Our slope is going to be what? Negative 1 over 4. Okay, how do you find a perpendicular slope? Yeah, change the sign and flip the fraction. If you're like, what fraction? Okay, put it over 1. Now it's pretty simple. Change to positive, and then you flip that 4 over 1 and it'll become 1 over 4. So our m value is a positive 1 over 4. Are you with me? Okay, now all I did with this equation was change the slope-intercept. Why? So I could find out what slope that equation had. Why? So I could actually change the sign and flip the fraction to get my slope. Okay. After that, I don't ever have to mess with this stuff again, right? Now I have my information here. I have a point, I have a slope. Yep. Should we go with point slope form or stick with just slope intercept?
Point slope form.
Point slope form. All right, what is point slope form? Y minus y1 equals m, parentheses, x minus x1. Let's plug it in with blank spots. Y minus blank spot equals blank spot, parentheses, x minus blank spot. Our y1 value is -3. Our m value is 1/4. Our x1 value is -4. Anytime you have minus minuses, change to plus plus. What do I have? I have y plus 3 equaling 1/4 parentheses x plus 4. Now, if they asked on the instructions to write your equation in point slope form, we would be done, but they say slope intercept form. So all we have to do is distribute 1/4 times x, that's 1/4 x, 1/4 times 4, that is a positive 1. If you don't understand that, let me write that work on the side right here. 1/4 times 4, you could just see that those numbers will cancel, leaving you just 1, which is why I have just a plus 1 right here. Let's rewrite everything else. We have the equal sign, we have the y, the plus, the 3. I need to get y by itself, subtract 3, subtract 3. Our final slope-intercept form equations, y equals, because that canceled out, you have y by itself equals 1/4 x, this becomes a -2. Y equals 1/4 x minus 2. Y equals 1/4 x minus 2. This is the equation that is your answer. They want your slope-intercept form equation. That is the slope-intercept form equation that passes through the point -4, -3, and is perpendicular to this given equation. Jumping to number 14, what do we have? We have a point that our line has. Our point is x1, y1, which is -6, 5. And they also tell us that our slope, our line is perpendicular. Perpendicular. Now, what does that mean? That the slope that this equation has, ours is going to be an opposite reciprocal slope. You cannot see slope right here. This is in standard form, ax plus by equals c. You don't have an m in standard form, so you need to get y by itself. You need to get it in y equals mx plus b form so you could actually see the m. So let's get y by itself. By subtracting x, we're going to have -y equals -x plus 5. Final step would be to divide everything by -1 or multiply everything by -1, but the bottom line is all the signs are going to change. So my slope-intercept form equation is +y equals +x minus 5. This is the same equation, but written in slope-intercept form. That's this equation down here, y equals x minus 5, is this equation up here, x minus y equals 5. It's the same equation, it's the same line. I just changed it from standard form to slope-intercept form. Now, why would I do that? Because now I could see that the m value is 1. And if my line, if my slope has to be perpendicular to this slope, then that means I need to change the sign and flip the fraction. Now, if you're thinking, wait a minute, that's not a fraction, make it look like a fraction. So what will our slope be? Our slope. -1/1, which is just -1, right? So there's our slope that's perpendicular to that slope. Okay. And we also have a point. You guys want to go with point slope form again? I for sure would go with point slope form if you don't have any fractions involved. Whoops. If you don't have any fractions involved, it's really easy. Check it out. Y minus blank spot equals m. I'm going to leave a blank spot, parentheses x minus blank spot. The y2 value goes right here, so that's going to be a 5. The m value is -1, that goes right there. And the x1 value is -6, that goes right there. Maybe I should have written the whole thing, sorry. Y minus y1 equals m, parentheses x minus x1. Okay. So once you plug it in, the minus changes to plus, and we distribute. -1 times x is -x, -1 times +6 is a -6. Bring down the equal sign, bring down the y and the -5. Final step is to add 5, and here's your answer, your equation slope-intercept form, y equals -x minus 1. Y equals -x minus 1. Would anybody like to do it the other way just for kicks with the y equals mx plus b?
I like kicks.
You like kicks. All right, so let's go the other way. So let's pretend that we didn't do any of this work. Okay, let's pretend that we know the slope is that, and we have x and y values, and we want to only use y equals mx plus b. Well, my m value is -1. I want to put that right there where the m's at. My x value is -6. I want to put that right there where the x is at. And my y1 value is 5, which I'm going to put right there where the y is at. So let me write this out. Instead of y, I'm going to put a 5 equals m is -1 times x. X is -6 plus b. So I really have a -1 times a -6, which is a +6. So +6 plus b equals 5. Solve for b, subtract 6, you'll get a -1 equals b, which means that your b value is -1. So once you know that your m value is -1, which we got from the beginning, knowing that it's parallel to this guy, or perpendicular to this guy, we know that our m is -1, and we just found that b is -1, then we'll be able to plug in the m and the b into slope-intercept form, which is y equals mx plus b. So if you plug in the m of -1 in front of an x, that'll become a negative. You don't even need to put the 1. And you put the b -1 right there as the last number, that's a -1. So it's just an alternative way of doing it. I personally prefer getting my point and getting my slope and going with point-slope form and then distributing and then moving, and it's in slope-intercept. But if you only want to stick to y equals mx plus b, you could write it out, substitute your x, your y, and your m all into y equals mx plus b. That way you could solve for b, and then once you have b and m, then you could substitute that back in to slope-intercept form, and you have your slope-intercept form equation. Whew. I guess another? 17, let's do number 17. Let's look at this equation first. I want to get a slope out of this equation. That way I could get my perpendicular slope from this equation. So I can't even see the slope yet. It needs to be in y equals mx plus b in order for me to see the slope, the m value. So I'm first going to begin by subtracting x and subtracting x. I will have a -6y equaling -x plus 2. Then I'm going to divide everything by -6, divide by -6, divide by -6. There's an invisible 1 or a -1 in front of that x. So my slope-intercept form equation is y equals a negative divided by a negative is a positive. So I'll have a +1/6, of course, with an x. And then the b value will be a -2 divided by 6. You cannot do, but you could reduce it to a 1/3. But in reality, all I care about is my slope. Remember, the only thing that really matters with regards to this equation is that you get your perpendicular slope from this slope. So this slope is 1/6. That's the slope that this equation has. That means that my equation is going to have a slope value that is an opposite reciprocal of that one. What is an opposite reciprocal of 1/6? So that become? -6. That's your slope value, -6. Okay, so our slope is -6, and they tell us that our line passes through the point 2,4. Because I have a point and a slope, I am going to go with point-slope form, which is y minus y1 equals m parentheses x minus x1. And then, of course, I'm going to use point-slope form with blank spots to plug in my values. And the y1 value is 4, that goes right here. The x1 value is 2, that goes over here. And the m value is -6, which goes right in here. So this is my point-slope form equation, but they want it in slope-intercept. They don't want parentheses, they want y by itself. So let's distribute. -6 times x is -6x. -6 times -2 is +12. Bring down the equal sign, bring down the y -4. We almost have the y by itself. All I need to do is get rid of that -4 by adding 4, canceling out. What you do to one side, do to the other side, add 4. I will now have y equals, my m is -6x plus b, which in this case is +16. There's your y equals mx plus b equation that is perpendicular to the given equation over here, perpendicular to that slope, and passes through that point right there. Excellent question. Would keeping it in y equals mx plus b and not using point slope form, would it be more work? In reality, I think it's just about the same. Okay, so it's just whatever you feel better with. And the only reason why I usually pick, oh, I have a point, I have a slope, I go a point slope, it's because when you do y equals mx plus b only, then you're going to substitute the y, the x, and the m into y equals mx plus b, and then you solve and get b, and then you have to substitute again to get your final answer. It's substitution twice, I mean, which is totally fine. If you like that, go for it. But I like seeing a point, seeing a slope, plugging it into point slope form, and then after that, just distributing and moving, and you'll have it in slope intercept.